Okay, for the examples, we want to write the letter of the figure that illustrates each triangle named. So we're looking for an equilateral triangle. So we want to look for something where all the sides, because equilateral is named by sides, are the same. So they're going to be marked with the same markings. So the one that fits that description is G. An obtuse scaling triangle. So this has two classifications. One is that one of the angles in the triangle is greater than 90. The other is that it's scaling, meaning none of the sides are marked congruent. So we need to find where an angle looks like it's obtuse and none of the sides are marked. So none of the sides are marked here, none of the sides are marked here, none of the sides are marked here. Well, this has a right angle, so it's not obtuse. This one, all the angles look like they're pretty small, less than 90. So it's not obtuse. But this one here, this angle is clearly greater than 90 and none of the sides are marked. So it's going to be E, obtuse scaling. The next one is asking for a right isosceles. So it's got two things as well. We want to find the right angle marking. That's with a box in the angle measure. And isosceles, so we're looking for two congruent sides or two side markings. So D has a right angle, but it doesn't have any sides marked. And it doesn't really look like they're all the same length anyway, or two of them are the same length anyway. But if we come over here, here's our right angle, and here's our isosceles, two congruent sides. So 3 is H. Acute scaling for number 4. Well, acute means that all the angles are less than 90, and scaling means none of the sides will be marked. So here we have 1, 2, 3 congruent angles. But it's not scaling because if all 3 of these angles are congruent, then all 3 of those sides are congruent. We don't have to mark the sides in that one because the 3 congruent angles implies the 3 congruent sides. So it's not B. Here we do see that all the angles look like they're less than 90. And we don't have any side lengths marked. So that means it's scaling. So acute scaling is C. Obtuse isosceles. So we're looking for an angle greater than 90, and we want to look for two sides marked because isosceles means two congruent sides. And I can see that right here at A. Isosceles, or obtuse because this is greater than 90, isosceles because the two sides are congruent. Equiangular, that means all the angles are 60 degrees or all the angles are marked congruent. So we have 1, 2, 3 equal angles. Right scaling. So we want to find a triangle with a right angle and none of the sides marked. So that would be D. Right angle and none of the sides are marked because scaling means no sides are congruent. And then finally we have an acute isosceles triangle. And it says not equilateral because an isosceles triangle could be equilateral. So acute isosceles means we want all the angles less than 90 and we want two sides congruent. So here's acute, 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 and here's isosceles. Okay, in this picture it asks us to find the measure of each angle. And before I go one at a time to look for the angles, I'm just going to start with the big picture and see what I can fill in from there. So I'm going to go with this right angle thing. That's really easy because if this is a right angle, if you have one right angle and 4 corners, then all of them are also right angles. So if this is a right angle, then remember vertical angles are congruent. You have your linear pair here, so these are 90. You have your linear pair this way, so this is 90. So all those around there are 90 degrees. Here we have vertical angles again, 53 and 53. Angle 53 and angle 2 are vertical. So angle 2 is 53 degrees. We also have a linear pair. Angle 1 and angle 2 form a linear pair. So a linear pair is supplementary. That means they have a sum of 180. So I would take 180 and subtract 53, and I would get 127. So angle 1 is 127. And then finally, we have the sum of the two remote interior angles, their sum, 90 plus 53, equals the exterior angle. The sum of the two remote interior angles, 2 and 4, equals the exterior. So 90 was angle 4 and 53 was angle 2. That equals 143. And then finally, angle 5 and angle 6 form a linear pair. Angle 5 and angle 6 form a linear pair, so they also have a sum of 180. If 180 degrees is given and 143 is taken, then what's left over is 37. So that's angle 5. So now we filled in all of our angle measures, and we can fill in the rest of this up here. Angle 1 was 127, angle 2 was 53, angle 4 was 90, angle 5 was, where's angle 5? 53, and angle 6 was 143. Number 14. It says solve for x. We have 1, 2, 3 angles given in a triangle. If you recall, the sum of the 3 angles of a triangle equal 90 or 180 degrees, sorry. And the reason I said 90 is because if 90 degrees is already taken, 90 degrees is already taken, that means that 90 degrees is left between these two angles. So 2x plus 8 plus 4x minus 2 equals 90 degrees. If you're not comfortable with that way, you can go back and do the sum of the 3, 2x plus 8 plus 4x minus 2 plus the 90 equals 180. So either of these will work. Alright, pause the video and see if you get what I get. Okay, and you should get x is 14. If not, raise your hand or ask a neighbor where you went wrong. Okay, number 15. You have an interior angle, and then you have the exterior. Remember, the exterior angle sum theorem says that the sum of the two interior angles equals the exterior. So if I add 4x plus 12 to x minus 4, it'll equal the exterior angle 138. Okay, pause the video and see if you get what I get. And you should have gotten x is 26. Okay, go ahead and pause the video and see if you get number 16. This number 16 will be very similar to number 14. And for number 16, you should get x is 21. Alright, for number 17 and 18, this is going to get us into congruent triangles. A correspondence statement is your congruency between the two triangles. Remember, you're matching angles to sides. So angle Q, we want to know what angle has the same markings as angle Q, and it needs to go here. So angle Q has one arc next to it. It's going to match up in the same position as P, because P has one arc. L has 2 arcs, so it's going to go in the same position as C. And B has 3 arcs, so it goes in the same position as N, 3 arcs. Okay, number 18. C has vertical angle here. I'm going to put 3 arcs because 2 and 1 are already taken. C and C are vertical angles. So we have C is going to be in the same position as C. D has 2 arcs, is going to go in the same position as B. And E, 1 arc, goes in the same position as A.